In this short video, we are going to learn how to solve for the equilibrium in a market that has a dominant firm and a competitive fringe. Let's suppose that the market for light bulbs has many small firms and one dominant firm, Lumilux. The demand for light bulbs is given by Q equals 90 minus 3P, where P is the price per bulb and Q is the number of bulbs in thousands. We are also told that Lumilux has a constant marginal cost of $4, and then all the smaller fringe firms combined have a supply curve given by 2p minus 10. I want you to notice the notation. This is the supply of the fringe, so I have this subscript F to indicate the fringe. Our goal here is to determine the equilibrium price, the number of bulbs supplied by the dominant firm, and the number of bulbs supplied by the fringe. So what do we need to know in order to answer this question? We need to know the demand curve. We also need information about the dominant firm's costs. Here we're told marginal cost, that's enough. We also need the fringe supply curve. That's the best case scenario, it makes the problem faster to solve. But if we don't have the fringe supply curve, we can also solve this problem with information about the fringe's costs, as well as the number of firms in the fringe, because with that information, we could derive the fringe's supply curve. So how do we go about solving this question? The first thing we need to do is find the residual demand, which is just the difference between the total demand and the supply of the fringe. We're really figuring out how much demand is going to be left for that dominant firm. From that residual demand, we can find total and marginal revenue. What do we do with that after then? It essentially becomes a monopoly question after that point. We're going to set the residual marginal revenue curve equal to marginal cost to figure out the dominant firm's optimal choice, their quantity. Then we'll plug that Q into the residual inverse demand to find price. Then we have to move away from the monopoly world and ask ourselves, what about the fringe? Well, the fringe is going to supply according to their supply curve, so we just plug the price into the supply curve to figure out the number of units supplied by the fringe. So this question is really like a monopoly with a twist, because in the middle, we're solving it just like a monopoly question. But the beginning requires a little bit of work where we figure out the demand that's actually available to that dominant firm. So let's solve this question. Here's what we know. We have a demand curve, a marginal cost curve, as well as the quantity supplied by the fringe. We are trying to find the equilibrium price, the number of bulbs supplied by the dominant firm, and the number of bulbs supplied by the fringe. The first thing we need to do is find the dominant firm's residual demand curve. And turns out that the residual demand is just equal to the total demand minus the supply of the fringe. So in this case, QR, I'll use a lowercase r here, R is equal to Q, which is 90 minus 3P, minus the supply of the fringe, which is 2P minus 10. Parentheses matter here, so make sure you use them. From here, we can write the residual demand as QR equals 90 minus 3P minus 2P plus 10. Simplifying that, we get 90 plus 10 is 100. 3P and 2P makes 5P. And that's the residual demand. So notice it's just an exercise in subtracting out what the fringe is going to supply at every price level. Once we have that residual demand, we can start thinking about the dominant firm's profit maximizing behavior. Functionally, they are a monopolist, so we need to find marginal revenue, and to find marginal revenue, we need total revenue, and to find total revenue, we need inverse demand. So the first thing we're going to do is we're going to find residual inverse demand. That's just a really jargony way of saying we're going to solve our demand curve for P. So I'm going to start rearranging my demand curve. I have 5P is equal to 100 minus Q. Dividing both sides by 5, I get P is equal to 20 minus a fifth Q, or if you prefer, 0.2 Q. Now, to make this a little more clear, we'll call this PR. It's the residual inverse demand. And what equation is this? We can call this equation 2, and the original residual demand is equation 1. Now, from our inverse residual demand, we can find the total and marginal revenue available to the dominant firm. We'll call that residual marginal revenue. So the total revenue is equal to Q times P, where P is 20 minus 0.2Q. So we can rewrite that as 20Q minus 0.2Q squared. This is our standard method for finding total revenue from an inverse demand curve. And then from here we can find marginal revenue. That's the derivative of our total revenue with respect to Q, which is 20 minus 0.4Q. So we have now found residual marginal revenue, and we can call that equation 3. So we are on our way to finding the dominant firm's profit maximizing behavior. The next step is to set that marginal revenue curve equal to marginal cost and solve for QR. QR here is going to be the amount produced by the dominant firm. So I have 20 minus 0.4Q is equal to that constant marginal cost of 4. I'm going to shuffle things around. 20 minus 4 is 16. Instead of 0.4Q, I'm going to convert this into a fraction. I do it in my head. 0.4 is 4/10. 4/10 simplifies to 2/5. Why did I do that? I did that so I could solve this by hand instead of using a calculator. Now if I want to solve for Q, Q must be equal to 5/2 of 16. Well, the 2 and the 16 cancel and become an 8, and 5 times 8 is 40. So I have that the amount that our dominant firm is going to produce and sell is 40 units, and we can call that equation 4. So our next step is to substitute 4 into 2 to find price. What am I saying here? I'm going to take the amount that the dominant firm wants to sell, 40, plug it into the inverse demand curve to find price. So P is equal to 20 minus 0.2 times 40. This 0.2 makes this a lot harder to answer than if we wrote this as a fraction. 0.2 is 2/10, which is also 1/5. So what's 1/5 of 40? 1/5 of 40 is 8. So P is equal to 20 minus 8, which is $12. So we have determined the dominant firm's profit maximizing behavior. They're going to set a price of 12 and supply 40,000 units. Why is it 40,000? Because the beginning part of the question told us that Q is in thousands. So while we solve for a Q that was equal to 40, we have to recognize that that's really 40,000. Step 3 here is to determine the fringe's response. How do I do that? I'm just going to take what I know about price and plug it into the supply curve of the fringe. So the fringe is going to supply 2 times 12 minus 10 units. So 24 minus 10 is equal to 14. And if it helps you, you can remind yourself that's really 14,000 units. So let's just make sure we understand this final solution. Our dominant firm is going to set a price of $12 and produce 40,000 light bulbs. The fringe responds to the $12 price by supplying 14,000 light bulbs of their own.